Okay, now we're on page 3 of the review, more multiplication. This time we're going to look at, with respect to multiplication, something called mental math. Mental math is when you do some work in your head and you do some multiplication. Typically, the method for mental math is to break a number apart, multiply two parts separately, store numbers in your head, and kind of add them together. So let me show you what I'm talking about. Let's say you had 12 times 15 and you wanted to do that. And you couldn't really do it on paper, so then what you could do it is you would do it in your head. So instead of, I know that 12 is really 10 plus 2 times 15. So that really ends up being 10 times 15 plus 2 times 15. So in my head, I would first take that, because it's 12 times 10, I would take the 10 from the 12, and I'd multiply that by 15, and I know that that's going to be 150. And then I store that away in my head. And then I jump over and do 2 times 10, and that's going to be my 30. So once I have the 30, I retrieve the 15 from my brain, and I put them together, and I get 180. So this is what mental math is. Mental math is when you take some, a variety of things, but this time we're doing multiplication. Could be division as well. But let's say we're doing multiplication. When you break apart one of the numbers, and in your head you show, how you could do this by breaking it down into two different parts. Again, let's try another one. 13 times 14. So I know that 13 is really 10 plus 3 times the 14. That's really 10 times 14, and plus it's 3 times 14. So 10 times 14, I'm going to put that in my head, and I'm going to say, oh, that's 140, and I'm going to leave that there for later. And then 3 times 14. 314 could be the same as 6 times 7, that equals 42. So I got the 42 in my head, or 140 in my head, plus I just did the 42, I put them together, and it equals 182. Let's move on down to a similar technique, and this has to do with estimation, and it has to do with when you're checking a number for reasonableness. What that means is, here's a calculation here. Is that a reasonable answer? Is this the answer for there? Is it close? Is this a close answer for that? And what we do with this in terms of estimation is, we've got the 39 and 41. Very quickly, 39, well, that's close to 40. And 41, that's also close to 40. So if I quickly round these together and then multiply that together, if I do 40 times 40, well, 40 times 40, I just do the 4 times 4 is 16, and then add the two zeros from here and here, and I get 1,600. So I've estimated what this is, and my job now is to figure out, is the number of my estimation close to the actual answer? Well, it is in this case. So this is a reasonable answer. Now, it depends on how much you have to round. In this one, luckily, I rounded one up and one down, so they pretty well gave me the same answer. Sometimes if you round them both down, you'll know that your answer, your estimation, is going to be lower than the actual. And if you round them both up to higher numbers, you'll know that this estimation ends up being higher than this. So hopefully when you estimate, the number ends up being kind of close, so at least you figure, oh yeah, this is a way of checking your work. So here's another one, 98 and 51. Well, 98 is really like 100, and 51 is, let's make it 50. Let's multiply those two together. So what I'm going to do in a situation like this, I go 5 times 1 is 5, and then I can just, in the end, add the extra zeros. 3 zeros is 5,000. Wait a second, the answer they got was 1,800. So this is not a reasonable answer, because when I estimated, I got it should be around 5,000, and they're not even at 2,000 for that one, so that one's not going to be okay. Let's get on to one more section here, is multiplying large round numbers. And again, the trick to something like this is to disregard the zeros that you see here for a second and just concentrate on the whole numbers. 6 times 9 is 54. Later on, we have to add in the zeros, 0 and 0, 2 zeros over here, so that ends up being 5,400. 5 times 4 is 20, plus 3 zeros left over there. 3 times 12 is 36, and 0, 0, 0, 0, that's 4 zeros. And that's how you do large multiplication of large numbers. Step number 1 is to work with the whole numbers first. And then step number 2 is to count and add the zeros. Count and then add the zeros. So that is page 3 of our review. And this is for both grades 5 and 6s. 5s would use the lower numbers, the 6s would be responsible for the higher numbers.